And it's that thing that you just said about this constant turnover process, which is particularly interesting. And of course, there's different rates of turnover depending on what we're thinking about.
Mm-hmm.
It depends I mean, we could just keep saying it depends throughout this entire podcast, and we will get into some contextual issues because I love it, as you know.
Sure.
But this, what's happening with this protein turnover? Why is there a process of protein turnover? And then if we sort of differentiate turnover of protein for sort of basic bodily functions, health, if you like, and then move that over to the training, adaptations, and performance piece.
There's a little bit of nuance in here, and I'll try and explain it sort of as simply as possible without, going too deep into this. But when we make proteins, we string together amino acids, and, that's the primary sequence of the protein. And then what actually happens is the protein begins to fold, and those are, catalyzed not by any reaction, but actually that's just the natural tendency of the protein. So that folding response is what creates a functionally intact protein. And it's surprisingly bad. So a lot of proteins get what we call misfolded. And misfolded proteins they're non-functional. So they're targeted for degradation, almost immediate degradation. They're made and they don't fold in quite the right way, and they're just degraded. The other point is the proteins that currently exist are damaged. They might be physically damaged in muscle. They kind of get ripped apart. They might be damaged through oxidation or nitrosylation, these sorts of processes that modify the protein so it's not functioning. It's almost as if every protein has sort of got a function, and yet, it's like your engine doesn't go right. So the idea is, well, we're going to tear it down, and instead of we're going to rebuild it, we're actually going to tear the whole thing out and put a new one in. And so that's the health and sort of maintenance aspect side of things. But you could almost imagine that in an athletic population who were subjecting themselves to these enormous energy expenditures, enormous high forces and everything, that the whole turnover process becomes more rapid. And so you've really got to keep up then with this constant turnover and hopefully tip it in a direction so that there's no net accumulation of damaged proteins, if you like. So in health, we talk about that happening slowly. I think in athletes, if you didn't have enough protein, it could happen more rapidly. And you don't necessarily experience, my protein stores are low. Take some time, but it will be manifest by suboptimal adaptations.
Yeah, and that's what's interesting with protein, isn't it? Because you think of carbohydrates, you think of storage within the body. You think of fat, we can see very obvious increases in fat storage, but muscles are,
yes.
Unfortunately, damn it, yes. But protein's a whole different thing, which is interesting how that sort of came about through evolution and so on. But ultimately, you've just added something there, and there's that business of this isn't even a particularly efficient process. Is that an accurate statement, or is it a different way of looking at it?
Yeah, I think, when you look at proteins that are made, the percent of proteins that are made and actually are functional, it's not particularly efficient, but we're pretty good at sort of recycling some of those amino acids that come from the breakdown of proteins, but obviously not 100% so. And that's why we need this sort of daily infusion of these amino acids to put the blocks back into the pool so that the pool's ready to respond to the next time it gets called on to make new proteins. So, the pool's primed all of the time, but when you feed is the only time when amino acids are flooding into tissues to really sort of kickstart the process and get new proteins made for sure.
Is that why we have become, particularly in sports nutrition, sports science, more obsessed with protein, things like the dose, the timing, how we spread that out, because there is this lack of storage mechanism within the body, and therefore it really is dependent on what we do on a day-to-day basis. Is that why?
Yeah, I think that's exactly the point. There are some people who are sort of the opinion that maybe you could put some of this protein into gut tissues or something like that and then release it later. There's actually no evidence to support that, but the theory is that there's no sort of little protein storage bag when you ingest protein, amino acids go up in your blood, and you have to use them during that period in which they're elevated, because that drives the inward push of those amino acids into tissues, and so they get used. They kind of leak out a little bit later, but not all of the essential amino acids come back, and that's really the key part of 20 amino acids, 9 we need for sure. It's sort of like bricks in a wall. You need all 20 bricks, but the 9 bricks, that protein that you're eating, that's what it provides.